Dear students, we are going to learn about language of chemistry. Like other languages, chemistry has its own language, and we are going to learn about language of chemistry. Let us understand what we have to start with. The substances are of two types, elements and compounds. What are elements? Elements are substances which contain single type of atoms, same type of atoms. What are compounds? Compounds are the substances which contain atoms from different elements. So that is elements and compounds. Next, how are elements expressed? How are elements represented? Elements are represented using symbols. And the symbols were for the first time used by a scientist called Berzelius. What are symbols? As per Berzelius, the symbol of an element is the first letter of the name of that particular element. For example, if it is carbon, the first letter is C. The symbol of carbon is C. Symbol of phosphorus is P. Symbol of nitrogen is N. Symbol of sulfur is S, etc. Now, for the elements where first letter is common, then along with the first letter, we have to use a suitable letter from the name of that particular element. For example, symbol of carbon is C, and calcium also starts with C. The symbol of calcium is C along with the other letter in the name A, that is Ca. The symbol of calcium is Ca. Symbol of chromium is Cr, etc. Now, some elements were popular by English names, and some elements were popular by Latin names. And for Latin names, the symbols are derived from their Latin names. For example, if it is copper, then in the Latin language, copper is known as cuprum. The symbol of copper is Cu. Symbol of lead is Pb, because in Latin language, lead is known by plumbum. Iron is known by ferrum, so the symbol of iron is Fe. So these are the symbols of the elements. Fine. How are we going to represent compounds? The compounds are represented by the corresponding symbols of the elements from which the compound is made. For example, sulfuric acid. Sulfuric acid is expressed as H2SO4 because one molecule of sulfuric acid has 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen. Symbol of sodium hydroxide is NaOH because one molecule of sodium hydroxide has 1 atom of sodium, that is Na, 1 atom of oxygen, that is O, and 1 atom of hydrogen, that is H. That is why symbol of sodium hydroxide is NaOH. So this is about the symbols of the elements and the compounds. Let us go to third point. What is chemical reactivity and what is the octet rule? We see that there are about 118 elements, and most of these elements are chemically reactive. They undergo chemical reactions. But there are some elements known as noble gases. They are chemically inert. They don't give any kind of reaction. The scientists tried to search for the reason for chemical reactivity and inertness. And they discovered that the elements which contain 2 or 8 electrons in the outermost shell of their atom are chemically inert. For example, noble gases. And that's why a rule was made called octet rule. What is octet rule? An atom is chemically inert if he has 8 electrons in the outermost shell. And if he doesn't have 8 electrons in the outer shell, he will try to complete the octet 8 electrons by giving electrons, by taking electrons, or by sharing electrons. So what is chemical reaction all about? Chemical reaction is giving of electrons taking of electrons and sharing of electrons. And that is about chemical reactivity and octet rule. Let us come to next topic, valency. Just now, as I said, the elements try to complete 8 electrons in their outermost shell. Doing so, the elements are going to give electrons, take electrons, or share electrons. And the valency is the number of that electron. The number of that electrons which are given, taken, or shared by that particular element. That is known as valency. Valency is a positive number. Okay. So, the element is giving electrons and taking electrons. If the element gives electrons, obviously he gets a positive charge and he forms what is known as the positive radical. If the same element takes electrons, then the atom is going to get negative charge. And as a result of negative charge, he forms what is known as negative radical. So we have a positive radical and we have a negative radical. Now, what different types of positive radicals are there? A positive radical may have plus 1 charge, plus 2 charge, plus 3 charge, plus 4 charge, up to 4. And a negative radical similarly may have minus 1 charge, minus 2 charge, minus 3 charge, and minus 4 charge. Now, something more about radicals. A radical may be single element radical. For example, sodium, potassium, calcium, magnesium. Or a radical may be multi-element radical. For example, ammonium ion. Ammonium ion is a positive radical bearing plus 1 charge, and ammonium radical is expressed as NH4, NH4 plus 1. So we have a positive radical and we have a negative radical. Let us now go to understand how to write a molecular formula for a given compound. The first example, let us take, is aluminium sulfate. So we are to write the formula for aluminium sulfate. What is aluminium sulfate? Aluminium sulfate is made from a positive radical called aluminium and a negative radical called sulfate. So what simply we have to do is write aluminium separately and write sulfate separately. Aluminium and sulfate. What is the charge on aluminium? Charge on aluminium is plus 3. Charge on sulfate is minus 2. Write the numbers without charge, and cross multiply. Multiply 2 with aluminium and 3 with sulfate. So what do we get? We get aluminium Al2SO4 thrice. Al2SO4 thrice. And that is the molecular formula of aluminium sulfate. In similar fashion, the formula for magnesium chloride and calcium oxide can also be written. For example, magnesium chloride, the formula is MgCl2, and the formula for calcium oxide is CaO. So, we have learned now how to write the molecular formula for a compound. What are things we have learned? We have learned there are elements and compounds. We have learned how to write symbols of elements and compounds. We have learned what is chemical reactivity and octet rule. We have learned what is valency. We have learned what are positive and negative radicals and what types of positive and negative radicals exist. And we have learned how to write the molecular formula of the compound. Thank you.